in this example of a hyperbola, we're given the equation of a hyperbola and we're asked to analyze the graph. Now, generally speaking, when asked to analyze the graph, there are several things we're going to be doing. We're going to find the foci, the vertices, the oblique asymptotes, the transverse axis, the conjugate axis, the center, and plot the graph. So it's just a ton of things we're going to do, and we're going to try to get all those details figured out. So in this case, the first thing I need to do is put it in the standard form for a hyperbola. So I need to get a 1 as my constant on the other side of that equation by dividing out the 16, all right? So I'm going to do that first, divide out the 16 to all 3 terms, and what I'll end up with is x squared over 4 minus y squared over 16 is equal to 1. All right, so the 4 and the 16 are nice. That tells me that my value for A is 2 and B is 4. Okay, the square roots of those two numbers. This also tells me, because the minus is with the y and the plus is with, or the positive is with the x squared, that the transverse axis is going to be horizontal, meaning this hyperbola is going to open in a horizontal direction. All right, so when I plot the graph of this thing, I'm going to start by plotting the center and plotting the box. Remember, I kind of mentioned a box that I'm going to draw, and it's going to be using the A and the B values. A is going to be in the x direction, B is going to be in the y direction, and that's going to give me my slope for the 2 oblique asymptotes. So we're going to start with that. I'm going to go ahead and get the graph going, and then I can find all the other information as I go here. Well, first of all, maybe I will list off a few things. Obviously, the center is at 0, 0. That one's pretty obvious. There's no shifting involved here. The transverse axis, that's going to be the x-axis, or we usually use an equation. So we use the equation y equals 0 for the transverse axis. The conjugate axis is going to be the y-axis, or x equals 0. Okay. Now, if those were shifted, obviously the transverse axis would be the k value, wherever the shift is, and the conjugate axis would be the h value. It shifts it horizontally. Okay. So those are my 2 axes. Now the vertices are nice. They're going to be at the value of A. So if I look at V1, that would be at -2, 0, and V2 is going to be at 2, 0. So those are 2 points I can grab right off of that A value. Okay, so from there, I'll pause just a moment. We'll get our graph drawn, or at least parts of it. I'm going to go ahead and plot this out. 1, 2, 3, 4, maybe 5. 1, 2, 3, 4, and 5. For now, we can always expand this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I could, yeah, like I said, I could expand this if I need to, or shrink it down if I need to. So my x direction, my box needs to go 2 on either side of the center. Center is at the origin, so I need to go 2 in either direction. So that's going to be over here to -2 and a +2. In fact, those where those 2 vertical lines intersect the transverse axis, those are going to be my vertices. Right? Those are at -2 and +2. So here's the center, vertex 1, and vertex 2. Okay, nicely positioned. Now, I need the other portion, the top and bottom of my box, or my rectangle. I call it a box, but it's a rectangle. And it's 4 units up and 4 units down from the center C. So I go up to 4, and I draw a horizontal line. Hopefully it's close enough to horizontal, and I go down to -4. right, and then I'm going to erase some of this excess. Try to get my corners in there pretty obvious. Okay, so there's my rectangle. Now why is that rectangle important? It's basically 2a by 2b in size, because if I connect the corners, run the diagonals, and extend them through the rectangle, that will give me the graph of the oblique asymptotes. Okay, so I'm going to draw one of them with a positive slope and one of them with a negative slope. Okay, so those are my two oblique asymptotes. Now, what are their equations? Well, the oblique asymptotes, they are going to be y equals plus or minus, remember it's the b over a, it's the y over the x every time. So b over a, I wrote a, b over a times x. Well, of course I would reduce that fraction, so y equals plus or minus 2x. And of course, if you look at the slope of this, you go up 2 over 1, up 2 over 1. That gets you 2 points on the line. And of course, if you went down 2 over 1, down 2 over 1, you're going to get points on the other line. All right, so it does give you the correct equations. So those are my oblique asymptotes. Let's see, what am I missing? I still need the foci, and I need to actually plot the graph. All right, the graph is probably the easier part here. Once I get this box set up in my oblique asymptotes, I start at the vertex and just make sure it has to run horizontally and it has to be asymptotic to these asymptotes, these lines up here. So this first side, it's going to be kind of asymptotic, kind of curves up toward that line. And on this one, similar, it's going to curve down toward that line. On this left side, curves down to the left and up to the left. Okay. Now what's interesting about these hyperbolas is that there is symmetry with respect to a lot of things. There's vertical symmetry, or symmetry with respect to the transverse axis. There's symmetry with respect to the conjugate axis, right, this way. And there's also symmetry with respect to the center, going through the center. It's kind of like origin symmetry, but if it's shifted, it's just center symmetry. So there's actually 3 different types of symmetry here. And of course, you can prove that by putting negatives in for these different variables and showing that the equation doesn't change. Obviously, it won't when you square the negatives, right? Okay, so that's a discussion just briefly about symmetry. But the other thing I haven't found are my foci. And remember, the foci are found using the b values. So we know that b squared is equal to c squared minus a squared. Remember, that's backwards from the ellipse, which is a squared minus c squared. And so when I plug those values in, c squared, oh, wait a minute, I don't have c squared. C is what I'm looking for, right? That's the focus, not the b. I think I said it wrong a moment ago, but I'm looking for c. So I plug in what I have. I know that b squared is 16. I know that a squared is 4. I add the 4 to both sides and then use the square root property. So c is going to be the square root of 20, which we know to be 2 root 5, or approximately, if you take the square root of 20, you get about 4.45, I think it was, or we'll call it roughly or approximately 4.5 or 4.47 or something in there. It's just under 4.5. So we'll go with 4.5. And so that's my C value. And so that means the focus 1, is actually going to be that subtracted from the center. So it's negative 4.5 comma 0. And focus 2 is going to be positive 4.5 comma 0. Of course, those are approximates. I'm not using exact form there because I'm really more interested in getting the graph plotted than being precise on these. So that was going to be focus 1. Ooh, bad looking F. Focus 1 and focus 2. That should be everything we need Remember then that analyzing the graph requires you to find all this stuff. Center, transverse axis, conjugate axis, vertices, foci, the oblique asymptotes, and the graph itself.